Alright, so in this video we will be looking over how to program our calculators using the TI basic language and the TI Connect software editor. And this skill is really useful because if you need to perform repetitive, lengthy calculations and use formulas all the time, this skill would be really useful if you could just give the calculator your variables and then have the calculator use those variables or use those parameters to give you the value or answer that you need. So to participate, you're going to want to need a TI-84 and the charging cable that comes with your calculator. Then you're going to use that charging cable to connect your calculator and your PC through the USB ports. Once you do that, the software TI Connect will show that you have a calculator connected. In this case, mine is called DC64. Once this is here, you basically have it confirmed that you can start programming. So if you press this button on the left, you can see all the programs and apps currently stored in your calculator. Now, some programs are in the archive, some are in the RAM, but today we will be coding a simple program in the RAM. Alright, so pressing the next button to the left, and then pressing New Program, we need to first give our program a name. So let's call it Quad Solve. And the reason why I'm being very restricted with the names is because the TI language does not allow program names to be very long, and the length is very restricted. Therefore, we kind of have to adjust for that. So starting off, when we solve for the roots of a quadratic equation, we use the quadratic formula and apply three coefficients, the a, and the b, and the c. If you don't know this, you can go ahead and search up the quadratic formula, but being a programmer, you should already know all this knowledge from Algebra 1. Okay, so first, we need to read the a coefficient, the b coefficient, and the c coefficient from the user. And this is how we do that. Right? So therefore, we have our first three lines of code, and let's go ahead and look at each part of the lines. So the input is a reserved keyword of the TI basic language, and the string over here is basically a prompt. So it's saying what the programmer is asking the user what they need. And then you store whatever user inputs into a variable. In this case, we'll call the variables accordingly A, B, and C, which is just easy for us to perform these calculations. So there we go. If we run these three lines of code, we will be reading the three variables A, B, and C from the user. And it will pop up on the screen, A coefficient colon, and then we're going ahead and type the value and press enter. And then the next, it will prompt for the B coefficient, then we're going to enter our value, and then the same thing for the C coefficient. And we'll look at how to run the program later on in the video. Okay, so now using these three coefficients, we need to solve for the roots. So this is how we solve for the first root using the quadratic formula. And all I'm doing here is really putting the quadratic formula into one line and then taking that value and putting it into a new variable called d. And the reason why I'm labeling these A, B, C, and D is because in the TI basic language, variable names can only be limited to characters A through Z. That's just how it is. It's a very limited language, but we're going to have to adjust for that. Anyways, this is the quadratic formula on one line, except this is just solving for one of the roots. Now, quadratic equations can have 1 to 2 roots. They can be real or imaginary, and that's what we're trying to solve here. So if you don't remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and then all of that over 2a, which is exactly what we're doing here. And it looks a bit messy, but parentheses are very useful in telling the calculator which calculation comes first. It's basically a good way to differentiate between the priorities of the calculations. So in this case, we have negative b plus. and then all that over 2a. So that's just one of the roots. So we can go ahead and display this first root and through the output function, which is called display. So the disp is a reserved keyword. Just like input, it is a function of the TI basic language. It is a built-in function. And here we're concatenating two data types into one string. So in this case, when we finish the program, it will say x equals and then whatever our root is, which in this case is d. So we're using the comma to kind of combine these two data types into one string. And then next we need to solve for the next root. Now it's very similar to that first line over here, except we need the minus. Right, there we go. So in this case we have the plus or minus. So with these two lines we're solving for two roots. Now the two roots might be the same, but a lot of the times they're also different. So the reason why we're using the same variable is that all we're doing is changing the value of d. Because right now, we've already displayed the value of d for this part of the quadratic formula. Now we need the second half of the quadratic formula. And the reason why we're using the same variable is that it's easier to just change the value of the variable. And for the calculator, it's also less memory to remember, because different variables open up new spaces of memory in the calculator. And to have the efficiency be high, we're going to have to limit the amount of spaces in memory that we're creating. So that's why we're using the same variable d, except with the minus. And then next, we still have to display the second root. So we do that using the disp again, and then we are concatenating these strings just like we did before. Alright, so there you have it. This is the program, the full program, using the quadratic formulas to basically solve for the roots of a quadratic equation. Alright, so now the important part comes up. Now we need to get this program into the computer's or into the calculator's RAM. So we need to press this calculator send button over here. And then we get an option of what we need to send. So yes, we're going to be sending the quad solve program, which is what we named it. The location is in RAM. And if you do have your calculator connected, the option to say which calculator needs the program will show up. You just need to select the calculator. Since you're only having one calculator connected, just go ahead and click that. And mine is called DC64. And then you're going to check this replace existing content button, because if you have multiple versions of code and you make a change to a new version, you need that program to replace the old version. So once you do all that, you just press send. And then I will be showing how to run this program in the calculator. Alright, so once you have sent the program to your calculator using the send options in the TI Connect software, you can go ahead and disconnect your calculator from your PC and go ahead and start running the program. So to run the program, press the program button, and when you see the name of your program show up, which is what we named it, quad solve, go ahead and select that option and press enter. Alright, so now you're basically telling the calculator that you're about to run the quad solve program. So to run it, just press enter. Alright, and we coded this program to do exactly this so far. So we're getting prompted for the a coefficient. So for a test scenario, let's put 1. And then for the b, let's put 4. And for the c, let's put 4 again. So what we're telling the calculator to do right now is solve the roots of the quadratic equation 1x squared plus 4x plus 4, which is basically the structure of the quadratic equation. Alright, so now to solve, we're just going to press enter. And then there we go. We get our two x values. In this case, they're both the same, -2 and -2. And you can check that this answer is correct by just going ahead and solving 1x squared plus 4x plus 4 equals 0 and solving for x. You will get -2. And then we get the done over here to show that our program ran successfully on this calculator.